Alright, welcome to this video. So, a system is a collection of devices that operate on an input signal or excitation to produce an output signal or response. So you can see in this diagram here, we have the system here, and then we have the input signal, and then the output signal. So that is the basic definition of a system. Then the next one we have control system, which is a control system is a system that can command, direct, or regulate itself or another system to achieve a certain goal. So any control system will be able to take the input signal, process it, and then generate the output signal. That is a control system. You can see in the block diagram here. But internally, in a control system, there's a controller that controls the amount of input signal that is required to process the input. That is internally, inside this block, we have another controller that controls the amount of input signal that is required to process the input. And then the process section processes the control signal, that is the signal that the controller processes, that the controller gives, is called the control signal. The process section of it will process that control signal and then generate the output. You can see here in this block diagram that we have the controller, we have the process, the input, and the output. So you can see here that the input signal goes into the controller, then the controller controls it and give the control signal to the process to process the output. So this is the block diagram of open loop control system. This is the block diagram of open loop control system. So you can see from the diagram that an open loop control system is a system that does not have any feedback from its output. The system open loop control system does not have any feedback from its output. This system does not depend on the output signal, it only depends on the input signal to give the output. As you can see in the block diagram, the input signal goes to the controller, then the controller gives the control signal to the process to give the output. There is no feedback to tell maybe the desired output is obtained or not. So in this type of control system, the accuracy of the system depends on the experience of the users. Since there is no feedback from the output signal to the input signal to tell maybe the desired output is being obtained or not, the accuracy of this type of system depends only on the user's experience. It depends on how good the user is with the system. So as there is no feedback from the output, the input is independent of the output signal. It does not know when to stop, when to start, and when to reduce or when to increase. It just gives what goes in is what comes out. That is it. And the type of control system is also known as non-feedback control system. Since there is no feedback from the output to the input, it is known as non-feedback control system. And then as there is no feedback from the output, the system cannot decide if the required output was obtained or not, since there is no feedback from the output to the input signal. And then the open loop control signal is also known as manual control system. The open loop control system is also known as manual control system. So let me give you an example of open loop control system. An example is if you take a bowl full of water, and you want to heat that water. You are not using a kettle now, you use the immerged water heater, the one that have the rod of dark oily rod. You put it inside the bowl with the water, then you turn it on. As the time goes on, it will start heating the water, raising the temperature. But this type of system, you cannot tell whether the water has get to the desired temperature. Maybe the desired temperature is 50 degrees Celsius or 40 or 70. You cannot tell, since there's no feedback from the output signal to the input signal. So the temperature that the water will get to depend on your experience, on your knowledge of it. So that is a very good example of open loop control system. When you put the heating rod inside the water, it will start increasing the temperature of the water. It does not tell how hot the water is, or how hot the water is, or maybe the water getting to the desired temperature. Another example is a bed toaster. We also have a traffic light that does not depend on the output signal to give the input signal. So that is the very good example of open loop control system. So under open loop control system, we have the disadvantages and then the advantages. So I've mentioned like 4 here for you guys. So number 1 is they have simple design and they are easy to construct. Since there's no feedback from the output to the input, they are easy to construct, and the design is very simple. Number 2 is they are economic, that is, they are very cheap. They do not require complex circuits. Then the next one here, we have another advantage. It says that they are convenient to use. They are very convenient to use, but it is difficult to measure the output. But they are very convenient to use. And then their accuracy is very low. They have a low accuracy since there's no feedback from the output signal to the input signal. They have a low accuracy. Then disadvantages is that they are poorly equipped to handle disturbance. That is, when there's a change, maybe in a room like this, you are trying to measure the temperature or stuff like that. When there's a sudden change in temperature or a sudden drop in temperature, they find it very difficult to adapt to it. And then number 2, they are not reliable. Since there's no feedback from the output signal to the input signal, they are not reliable. And then the last one is that they require recalibration of the parameter from time to time. And then there's limit control over the output. Since the output signal does not feed back into the input signal, there's little you can do about the output. So there's a limit control on the output. But closed loop control system. A closed loop control system is a system in which the controlling action of the controller is dependent on the output. It's a system whereby the controlling action of the controller is dependent on the output. That is, the signal that goes into the controller depends on the output signal. That is, there's a feedback from the input to the controller. And you can see here in the block diagram that there is what we call the error detector. It is the error detector that produces the error signal, which is the difference between the input signal and the output signal. So it is the error detector that determines that will give the signal that will go into the controller. Then the controller will give the control signal to the process to process it. And this thing, there will be constant monitoring of the output signal to check or to be sure that the desired output is obtained. So this type of control system is also called automatic control system or feedback control system. Since there's a feedback, you can see it in the block diagram that there's a feedback from the output back to the input. So it is called feedback control system or automatic control system. An example of this type of control system is we have the electric automatic iron that constantly monitors the temperature, the output signal, I constantly monitor it, then send it back as a feedback to the input signal to decide when to turn on and when to off. And then another example is your air conditioner that constantly measure the temperature to decide when the compressor will be on and when will not be on. So these are the example. And also the cruise control in your car. That's an example of closed loop control system. Constantly monitor the output signal to check whether the desired output is obtained or not. So advantages and disadvantages. We have the accuracy is very high. Since there's a constant monitoring of the output signal, the accuracy is very high, and then they are more reliable. It does not depend on the experience of the user. So they are very reliable and they are self-correcting. They constantly monitor the output signal to correct it, and they can easily adapt to any change in the environment. While disadvantages is that they are complex in design. Since there's a feedback loop from the output to the input, the design is very complex because there's a need for another circuit of feedback to be made. And number two is that they are very expensive. They are very, very expensive. And then the next one is that they can be slow to respond, since there's a need for the feedback signal to be given back to the input, so there can be some time delay in the output response. So this is it for this video of control system, open loop and closed loop control system. Thanks for watching.